Hey, what's up? B-Dog's back again, B-Dog's Maths. And just to remind you, this is part 2 of my functions video. And what you've got is the first part was notation and substitution. And the second part is inverse and composite. So we're going to look at these two now and how they work. So slightly more advanced, but should be manageable. We'll go through it so it makes sense to you, so you kind of get what it's meaning, even though it's written in some more technical jargon. Doesn't matter. It's about what's up in here. Yeah. Okay. So there we go. So inverse first of all. You need to understand about functions, and I've got a couple of functions we're going to look at. I'm just going to write them down on here. Function number 1 is this function. Let's call it f. Yeah, f of x. So let's say that f of x equals x squared. Dun, dun, dun. Yeah, x squared. I'm sure about my x looks real. Let's get that bit there. It's better. There we go. X squared. Alright, so what that means is when I place a number in, what comes out is a square number. Alright, so if I put 1 in, 1 comes out. If I come 2 in, 4 comes out, and so on. I'd like to look at 2 specific problems with this. Or 2, not problem really, but 2 things that happen. Let's say I placed 2 in, and out would pop what number? 4. Yeah, got that. Let's say I put -2 in. What would come out? Still 4. Did you notice that? So when the 2 went in, 4 came out. When the -2 goes in, still 4 comes out. Can you see that? So what we've got is 2 different numbers going in and the same outcome coming out. Yeah? So algebraically, I would write that down as f of 2 would equal 4, as well as f of -2 would equal 4. Yeah, it's got that. So that says a lot there. That says that you can choose multiple options and get the same outcome. More than one option, one outcome. Many options, one outcome. That's called a many-to-one function. And if you've got a many-to-one function, you can't find an inverse to that. Alright? Let's flip it. Let's go for a one-to-many. So really, we're talking about square root, aren't we? That's one of them. So if I said to you, g of x equals the square root of x, then you know that if I put 4 in, my answer could be 2 or -2. So I've got one number going in, but 2 options to come out depending on how restricted or not restricted, whatever. So that's a one-to-many function. And again, you can't find the inverse for that. But I digress. I haven't told you what an inverse function is. Alright? What is an inverse function? Well, right, so what is an inverse function? That's what we were just about to talk about before my camera decided to switch itself off. Yeah, I'm going to write down a function first of all. So I'm going to write down the function of h. So h of x equals 5x minus 3. There it is. So that's h of x equals 5x minus 3. And what I'm going to do there is I'm going to write down a mathematical example of that. So there it is. 2 goes to 7. I think that's correct. Let's have a look. If h of 2 means 5 times 2, which is 10, and then take away 3, which is 7. So 2 goes to 7. Yeah, happy with that. Awesome. An inverse function is one that will have a formula that turns 7 into 2. But not just 7 into 2. Any mathematical outcome from this h of x, taking the outcome and put it back to what you would have put in the first place. So reversing the idea. So in other words, times by 5, take away 3, giving you an answer. So basically what we're saying is that I want a reverse of that function there. Can you see that? So x goes in, I times by 5, I take away 3, I get an answer. What I want is a function to return that around and go the opposite direction. So add 3 first and then divide by 5. That's what I'm working out. So my new function would be called x add 3 then divided by 5. And hopefully that should work correctly, because 7 add 3 is 10 and 10 take away 5, 10 divided by 5 is 2. Yep, so 7 went to 2. If I put 5 in here, 5 5s are 25, 25 take away 3 is 22. If I put 22 in here, 22 add 3 is 25, 25 divided by 5 is 5. So yes, this reverses the process. This therefore is an inverse function of h. And how do I write that down? So notation wise, that is the notation. H to the power of minus 1 or negative 1 of x will equal this. So the inverse function of h is this one. The normal function of h is this one. The inverse is this one. Okay. The next clip I'm going to go through which a written example is how you would calculate this. But as long as you understand what you're trying to find, you can then know to be able to check your answers or you just know what's going on, which is a nice thing. Okay? Right, be right back. Okay guys, so here is a quick example then of how to find the inverse. I'm going to put an equation on here or a function on here that we already discussed earlier to not be, we weren't allowed to inverse it because of this one to many, or many to one option. This one's a many to one. If I put negative 2 in here, that becomes 4 minus 3. If I put positive 2 in here, that becomes 4 minus 3. So I get the same answer from 2 different solutions. So it's a many to one. I can change that problem by stating I'm only going to use positive numbers for x. So I can apply a condition, also known as a domain, right? So where you can only, the place you can only touch numbers from. So I'm only going to take numbers from the positive region, okay? And that makes it a one-to-one, so I can find an inverse. We need to be aware that the output here is going to become the input of my inverse. So whatever was y in here will be x in my new version. And that's something to remember. So whatever was y in the top equation will be x in this equation. So that x there, I'll underline it for you. This x here is actually the y from here. Okay? So let me rewrite this problem out as y, so this problem, as y equals x squared minus 3. Remember that this x is actually this y. Okay? We carry on and rearrange so I have this x on its own, because we're going backwards, remember. So my first thing to do is to add 3 on both sides, which leaves x squared here and leaves y plus 3 here. And remember, I say that's the first thing. No, the first thing was to put the equal sign down. So I've got things in order, and that's important. Alright, to get x on its own here, I need to do a square root job. So that leaves me with x here, and this will leave me with the square root of y plus 3. So the answer to my problem, remember that x there is actually this y here. Let me underline it. Yeah, so that x is actually the same as this y. Therefore, the f of negative 1 of that x that we just calculated here is this problem. But we're not going to put y, we're going to actually put x. Alright, so, and that is how we find the inverse. It doesn't get any more difficult a concept of rearranging to get x the formula, the subject, and then remembering that your new item, when you've got y, that item there will then be your new x. Okay? Looks like I'm going to have to do a separate video for for composite functions. Look forward to that in a minute. See you in a bit. Bye. Okay then guys, so now we're going to look at the word composite and what it means. We see it quite often. There it is, just so you can see the spelling of it. We see it often. To compete means to get many things together and compare the outcomes of each other. A compound fracture is where you have more than one bone that's involved within this fracture. Compound mixture, more than one element or substance in this mixture. Compound interest, more than one process. So composite, the word COMP, actually means more than one being involved. So what I've actually got here is more than one function. I've got the function of f of x equaling 3x plus 1. And I've got another function called g of x, which would be, let's call that x squared. Alright, so I've got two different functions. One function, other function. And the question might ask me to work out, or to find, or to calculate, or whatever, work out an expression for wow, that's weird. This is actually pronounced g of f of x. G of f of x. In other words, use the function f of x, get your answer, and plug that into g. So you actually go backwards through your motions here, rather than what you should read forwards. Alright, I'll try and show how that means. So first of all, I have to take what I had in f of x. I know that f of x equals 3x plus 1, and I'm going to plug that into this function. So my new g function will actually be 3x plus 1. So I'm taking the f of x and placing it inside the bracket, using that as the input for my g function. So what was my g function? My g function was to do x squared, but I haven't got x now. I've got 3x plus 1, so it's actually going to be 3x plus 1 all squared. Now, I'm not going to waste your time on expanding brackets here, but that you can keep that as that. That's not a problem, unless it asks you to expand and simplify. Then you'll have to expand and simplify that, which will give you 9x squared plus 6x plus 1. And some of you will be able to do that from that stage to this stage. If not, then you have to write it out in long ways. But hopefully that tells you what I mean about g of f of x. Okay, g of f of x. What happens if I'm asked a question like, some more special amount of space, I have, good. My next question might be find 2g of x. So my compound is now I'm doubling my g of x output, which is quite straightforward really when you think about it. The g of x is x squared, so 2g of x would be 2x squared. So that would be 2x squared. You might be asked to do things like this: 2g of x add f of x, which is that add that, and then you're going to have 2x squared plus 3x plus 1. So you get to play around with the idea, but as long as you understand that if you have this concept you have to go backwards through the steps, you're going to be alright. Okay? Any other questions on that, feel free to get back to me, but that's composite. Alright.